Again, today we're learning the last, this is the last section of new material for our test. I'll probably only get halfway today, and then tomorrow I'll cover the rest of it and special cases. So, before we go in and do complex graphing of rational functions, we are going to start off with just your basic transformations. Now, we talked about this, I think in this class, it might have been 7th period, but quiz A, number 3. So many people got quiz A, number 3, wrong. Which function is a polynomial? Okay, so we don't know clearly. What is a polynomial? On the very front page of our notes, a polynomial function of degree n is a function of the form ax squared plus bx plus c, ax cubed plus bx squared, all that. And n is a non-negative integer. Well, y'all, what is the exponent for a? 1/2. Is 1/2 an integer? No. What is a? What type of function? A is wrong, but what type of function is a? That's a square root function. It's not a polynomial function. B. B is what we're learning today. B is a rational function. C. C is linear. Linear functions are polynomials. Y'all, what is D? A trig function. Is that a polynomial? No, we haven't even done that. Why are y'all choosing that one? Anyways, the answer is C. Here's why it's not B. Because a lot of y'all chose B. Hold on. Shh. The reason it is not B is if you look over to the next page, the definition of a rational function, where did my highlighter go? A rational function is a function where you have p of x and q of x, and you're dividing polynomials. A rational function is when you are dividing polynomials. Okay? So, we're going to get to this page in just a second. Before we do that, we're going to talk about the rational function parent functions. You should know what the parent function 1 over x looks like. We did that last unit. Yeah, it's in which quadrants? 1 and 3. And do you agree that it has an asymptote at? Why does it have an asymptote at 0?
Because it just approaches.
Can you divide 1 over 0? No. And then what happens here? And then my biggest advice for rational functions, because y'all do get confused with them, is when in doubt, make a table. Or plug in your head. What is 1 over 1? So the 0.11 works. What is 1 over 2? 1 over 3, 1 over 4. What's going to happen here? Keep getting closer and closer to 0. What about 1 over negative 1? So negative 1. 1 over negative 2. And there you go. Now, I do not need your arrows to go past the graph. It's not necessary. But it needs to be the majority of the graph. If you sit here and give me this, I'm going to count off. Like, what is that? The same way, I do not need arrows on your asymptotes. You have to have arrows on the graph. But I want your asymptotes to go the whole graph. Okay? What is my domain here? So you could either say negative infinity to 0, union with 0 to infinity, or x such that x does not equal 0. Either one works for me. What's the range? So you can either do the same thing Or you can do y such that y does not equal 0. Either way you can write it. What is your vertical asymptote? X equals 0. Your horizontal asymptote is at y equals 0. What questions do I have? All right. What about my next problem here? Oh, by the way, can you box this equation? All of these are, or this is an odd function, just a reminder. This one is odd. So I'm going to take that parent function and do what? Here. I'm going to go right 1. And I'm going to do what? Go up 2. And how is that going to change this graph? Change my asymptote. My vertical asymptote is going to go right 1. My horizontal asymptote up 2. Is there a stretch here? No. So don't you agree it's going to kind of be right here, like from, we'll call this my new origin. It'll be just like 1, 1 right there. Again, if you're unsure how to graph it, plug it in. What is my domain here? Or you can write negative infinity to 1, union with 1 to positive infinity. Bless you. Is that a sneeze? What's my range? Y such that y does not equal 2, or negative infinity to 2, union with 2 to positive infinity. Yeah, I'm going to go ask Miss Nelson what's going on.
It's Cal. Don't worry.
No, it's just Cal jumping up and down to see. He's probably going like this right now. Something like that. He does it.
All right. Vertical asymptote is at x equals 1. Make sure it's an equation. Hoivux. Horizontal asymptote is at y equals 2. Last one right here. Does this shift at all? It doesn't do up or down. What is this going to do? It's going to vertically stretch. And again, if you don't know, when in doubt, make a table. If you're not really sure what to do, make a table. If I plug in negative 2 for x, what's 2 divided by negative 2? Negative 1. 2 divided by negative 1. 2 divided by 0. Undefined. So what's going to happen at 0? An asymptote. Negative 2, negative 1, negative 1, negative 2. And we know this didn't shift up at all. So we know the horizontal asymptote is going to be on the x-axis as well. What if I plug in 1 to this equation? What's 2 divided by 1? 2. So at 1, 2 is a point. And 2 divided by 2? So this just made it a little bit stretched from my origin. That's all it did. All right, fill out the domain, range, and asymptotes, please. Don't you agree they're the same as the parent function? Yeah, because we had no shifts. Are we okay with these transformations of the odd reciprocal function? Can I move on? What about the even reciprocal function? What about f of x equals 1 over x squared? How is this different than above? It's going to be which quadrants? 1 and 2. So we're still going to have, what's 1 over 0 squared? Not 0, undefined. We're still going to have an asymptote on the x and y axis. 1 squared is still 1 right there. Just this time, what is negative 1 squared? It's positive 1. So we're in quadrants 1 and 2. Is that going to change my vertical or horizontal asymptotes? No. Is it going to change my domain? Oh, let's do negative infinity to 0. By the way, I'm doing domain different ways just to show you that it's acceptable either way. If you prefer a specific way, you can write it like that every time. I'm just switching it up for those of you that like to write it different. What is going to change, though? What is the range going to be here? So you can either write 0 to infinity, or how can you write this? Y such that y is greater than 0. You don't have to write both, but you need to write it one of these ways. I want you to do the next two on your own. Go. And be aware these are squared. No Danica. No Ava. No Edwin. Oh, Edwin, why aren't you taking notes?
I was, miss.
Where's your paper?
I gave it to Duncan.
Don't lie to my face. It's rude. Get out your notes. Let's go.
I'm taking next one.
Edwin? Don't make me kick you out. Yeah, you just skip 4th period. Take your notes. Then why'd your teacher cut you absent? Look up to see if you did your graph right. Did anything change at the top in the blanks? The range. The range is the only thing that's going to change. What's the range here? Negative infinity to 0. Or y such that y is less than 0. Edwin, get out your packet. Open it to page 10. Come on. Last one. What is this doing right here? Left 2. I'm going to move my asymptote left 2. Am I going up or down at all? No. Your test is next Wednesday. Oh, I did that wrong. Oh. Why did I do that wrong? I did the odd This is squared, so what should I have done? I realized it right away. So be careful about that. Make sure you're paying attention. It's squared, so it's the even function. What's my domain? X such that x does not equal -2, or you could do negative infinity to -2, union -2 to infinity. What's my range? Vertical asymptote. And make sure you write x equals -2. And horizontal asymptote. What questions do I have about graphing the parent functions and transforming them? Y'all, what do y'all think the biggest mistake people make on this question on the quiz is? What I just did. Make sure you're paying attention to whether it's even or odd. Alright? Alright, turn your paper over and get out a highlighter. There are highlighters at the back if you need them. We are about to highlight, because we don't want to read this whole paper, do we? So we're about to highlight the important things so that they can catch your eye when you are confused. No, we're going to do examples. We're doing the first 3 examples, but we're not going to finish them today. Well, we might. This class we might finish them. That's a lot. Yeah. All right. Again, rational functions are functions where you are dividing polynomials. To graph rational functions, you are going to do the next 8 steps. Now, you did these in Algebra 2. However, I think, and y'all can correct me, I think you only had horizontal asymptotes in Algebra 2.
Yeah.
We're going to bring in something called an oblique asymptote. Did y'all do oblique asymptotes? No. Okay. Did y'all do holes in Algebra 2?
Yes.
Okay. We're probably not going to get to holes until tomorrow, but we're going to do everything else today. So, the first thing you are always going to do is factor if needed. You are not always going to need to factor, but factor if needed. Okay? Y'all have been factoring for a couple years now, so I don't think I need to go more into that. Step 1. Okay? Step 2 is find the restrictions. To find the restrictions, you are going to make the denominator equal 0. Again, I'm only reading what I'm highlighting. If you get confused, you do more. When you set the denominator equal to 0, that's going to tell you where your asymptotes are, which for your domain is going to tell you what it does not equal. So number 2, set it equal to 0. It'll tell you what it does not equal for your domain. What did I just say setting it equal to 0 does? It actually gives you your vertical asymptotes. So when you do 2, you also are going to do 4 today. Tomorrow we'll deal with holes, and that's going to change a little bit. But you're going to find your vertical asymptotes. And your vertical asymptotes, again, are when you make the denominator equal to 0. Okay? So we are going to pause for a bit. Not really pause, but we're going to stop highlighting for a minute. Does everybody have that highlighted already? All right, turn your paper over. We're going to do 1, 2, and 3 today in class. So number 1, I lied to you. 1, 2, and 4 in class. What does number 1 say we do? And by the way, on your test and your quiz, I am giving you all this. It's not like you have to memorize what to do. I'm going to give you each of these little sections. Thank you. You are good to go, unless you want to hear this again. All right, so can I factor this? You won't always have to, but can I factor this one?
Yes.
Yeah, where? Okay, y'all all look up. If you forget r of x, I will forget to give you points. Okay? It's an equation. I need an equation. So r of x equals x minus 1 is up top. What is x squared minus 4 factored? X plus 2, x minus 2. Starting tomorrow, we're going to look if it can reduce. Can this reduce? No. So because it cannot, you can actually scratch out reduce. And if it can't reduce, it's not going to have a hole. Scratch out that. Okay? Again, tomorrow we'll deal with reducing. Now, how do we find the restriction, state the domain? Set what equal to 0? The denominator. So what is x plus 2, x minus 2 equals 0? That's x equals positive and negative 2. So what is my domain going to be? And if that is my domain, what is my vertical asymptote? Where are my vertical asymptotes at? X equals 2 and x equals negative 2. Edwin, write it down. That makes sense? Draw your vertical asymptotes now. What questions do I have? Gerard, are you with me?
Yeah.
Questions? Alright, turn your paper over. We're doing number 2. Can we factor this? What are we going to start off with? What does the top factor to?
X minus 2 is 1.
I got x and x. I got 2 and 1. X what?
X minus.
Is that what y'all got? Can I reduce this? Be careful. Can I cancel these out? No, they're not the same. They would have to be the same. So be careful because you're going to want to cancel them out. You can't. Remember, don't kill kittens. You can't just cross out x's because you want to. Doesn't do that. So since I'm not reducing, there's no holes. So what do I do now? Set it equal to 0. What is x minus 1 equals 0? So the domain is x such that x does not equal 1.
Do we have to put a D dot now?
That's just saying what the domain is. Yeah. Which means, what is my vertical asymptote at? X equals 1. And please draw that. Questions so far? Alright, you do the third one right underneath it. Go. Factor it. Do the domain. And give me the vertical asymptotes. Example 3 on the bottom. Example 3. Sorry, I said it weird. We are doing numbers 1, 2, and 4 on the chart, but we're doing examples 1, 2, and 3. Yeah. I was talking about 2 different things when I said 1, 2, and 3 and 1, 2, and 4.
So you factor out 3x and you still have the 3 inside.
Yeah, be careful. I'm factoring out 3x on the top, so what's left? X minus 1. And on the bottom? It needs to be a positive 4, negative 3. Is that what y'all got? Can I reduce it? And I don't have a hole. What is my domain? Yeah, you can absolutely do a comma. For the domain, you can do a comma. I would prefer you not to do a comma for vertical asymptotes, because I want their equations. Yeah. What's your question for me? Question. You say you don't know what's going on.
You just said that.
I heard it. Y'all don't make me feel crazy. I'm not crazy.
Miss, I have a question.
Yes.
When our first ever break?
Your first ever brain break? We haven't done one all year long.
No.
I am.
When are we going to do Jeopardy?
Instead, I just let y'all do homework in class.
I need to get the logo.
What'd you say?
Jeopardy.
Jeopardy? Okay, oh, don't forget to draw your asymptotes right here. I would rather get through the lesson and then give y'all all of Thursday to do homework.
Why can't we do all of homework and
We don't have time. Alright. No, we're not done. Unfortunately. Alright, are we all okay with these 3 boxes? Yep, now we're going back to highlighting. Back to highlighting. I'm going to highlight in orange now. Let's switch it up. Okay. Oh, I'm going to do yellow real quick. Real quick, again, we're not talking about it, but if you can reduce, I do want you to reduce. And if you reduce, it will not be a vertical asymptote. It will be a hole. Again, I'm going to talk about that tomorrow. But just know those sections will come up. We'll do that tomorrow.
That's not orange.
I know, I'm doing orange the next section. Sorry. I said, oh, yeah, yellow. Just know reduce, hole, goes together. We're going to talk about it tomorrow. It can have asymptotes and holes, but what the difference is if you reduce, then when you set your denominator equal to 0, they both won't be asymptotes. One of them will be an asymptote, one of them will be a hole. Yeah, there's still restrictions, they're just not both asymptotes. But we'll talk about that tomorrow. Okay, now here's my orange. I think it's orange. We can debate over it. Now we're going to talk about horizontal and oblique asymptotes. That's orange. Okay. Now, there are 3 different types of situations for asymptotes, horizontal asymptotes. The first one is if the degree of your numerator is less than the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, it is bottom heavy.
I remember getting
That's bottom heavy. We like bottom heavy because it has a horizontal asymptote at y equals 0. Every time your horizontal asymptote is at y equals 0 and you're good. Questions? Okay, bottom heavy. So like right here, do you see how x squared is on bottom? X is up top. The higher degree is on bottom. That's bottom heavy. Yep. That's bottom heavy. Okay, turn your paper over. Next. If the degree of the numerator is equal to the degree of the denominator, we call this balanced. Everybody write that down. Balanced. So that's like having x up top, x on bottom. X squared up top, x squared on bottom. They're balanced out. If that's the case, Your horizontal asymptote is at y equals LC divided by LC. Horizontal asymptote at y equals LC over LC. Write that down. What the heck is LC over LC? It's leading coefficient. Look up real quick. Look up real quick. What are my leading coefficients here?
3 and 2.
That is where your horizontal asymptote would be. 2 over 3.
Ooh, I got you.
It's just the two numbers out front. That is only if it is what? Balanced, meaning x up top, x on bottom. X squared on top, x squared on bottom. X cubed on top, x cubed on bottom. Has to be the same exponent. Okay? Okay? Last situation, which is probably our least favorite, is if the degree of the numerator is greater than the degree of the denominator. What are we going to call that? Top heavy. I don't think you dealt with top heavy last year. If you took college algebra, you did probably. But for top heavy, you have an oblique asymptote at y equals mx plus b. An oblique asymptote is a slanted asymptote. So you have OA, and to end up finding what your y equals mx plus b is, we are going to do synthetic division, not long division. We are going to do synthetic division. Okay? Are you ready, kids? I was waiting for somebody to say, aye, aye, Captain. Y'all are so boring. Just kidding. There was your brain bait. Alright. Look up. You can look at the original equation. Top heavy, bottom heavy, balanced. Which one is this? So this is bottom heavy. Because it's bottom heavy, what is this? Horizontal asymptote at y equals 0. Bottom heavy is HA, y equals 0 every time.
Does OA have an intersection?
Well, we'll talk about that in a second. Okay? Bottom heavy, HA, y equals 0 every time. Be careful, guys, on your test. For some reason, you'll always forget to circle this and you get a point off. You know it, you just forget to circle it. Turn your paper over, number 2. Top heavy, bottom heavy, or balanced. This is top heavy, which means... No, that's balanced. Oblique asymptote. How did I say we deal with an oblique asymptote? We have to do synthetic division with this. What is going to go in my box? 1. And then my coefficients are 1, -1, -2. Chop it down, multiply, add. You do have a remainder of -2, but remainders do not matter in this situation. So what is my equation for my oblique asymptote right here? Y equals x. Oh, I forgot to graph that last one. Real quick. We got to graph y equals 0 here. Sorry. Just graph y equals 0. And then I'm going to have to graph y equals x. How do I graph y equals x? Go through 0, 0, then do up 1 over 1, up 1 over 1, up 1 over 1. It has a slope of 1 over 1. That is my oblique asymptote. Why are they having baseball senior night like your first game?
What? Yeah, bruh. Oh my
That makes no. It's not even a district game.
That's what I said.
It's a new coach. That's why. It makes no sense. It's the beginning of the season. Okay. Last but not least, number 3. Top heavy, bottom heavy, or balance? Balance. Therefore, this is horizontal asymptote at what? What are my leading coefficients here? 3/1. So y equals 3. So graph your horizontal asymptote at y equals 3. All right. Now, are we okay with top heavy, bottom heavy balance? Okay. I've been ignoring something for all 3 problems in this box. What have I been ignoring? Intersection point. Okay. What your teachers may have lied to you about before this class is that you cannot cross an asymptote. That is not true for horizontal and oblique asymptotes. It is true for vertical asymptotes. You cannot cross a vertical asymptote. But you can cross a horizontal asymptote. You can cross an oblique asymptote. Horizontal and oblique asymptotes are actually there. The purpose of them is for your end behavior. What are you approaching but not getting to? Okay? Vertical asymptotes are stopping. You can't touch those. So, we have to see if these graphs intersect at these asymptotes. The way that we are going to do that, if you have a reduced equation, I want you to use it. If you don't, I want you to use your original equation. So right here, just right below it, I'm going to write my original equation. 3x squared minus 3x over x squared plus x minus 12. And I'm going to make it equal to this asymptote of 3. How do I solve this?
Make it so that the top equals a 3 and make it the bottom equals a 1.
Okay, so like, are you saying do this over this? And then what can I do now? Cross multiply. So do you agree that's going to give me 3x squared minus 3x equals...
3x squared.
Wait, why not?
Well, because it's that times 1. It's the same thing.
Oh, you do know.
Yeah. And then 3x squared plus 3x minus 36. Are y'all okay with that?
Mm-hmm.
What happens to my 3x squareds? So then I have negative 3x equals 3x minus 36. They do not. Be careful, because that's a negative 3x and that's a positive. So I'm going to subtract 3x from both sides, which gives me negative 6x equals negative 36. So x equals 6. So what is my intersection point then? And it says a point. I need an x comma y. What's my x?
6.
What's my y?
3.
So this is going to intersect this asymptote at 6, 3. Questions, because it's weird.
Where is it for?
What is it for? On your graph, it's going to cross that asymptote right there. And only right there. Alright, let's do the next one. For my intersection point, what's your question? When we graph this, it is going to cross the horizontal asymptote right there. That's up. Okay, this one. I'm going to take my original equation. X squared minus x minus 2 over x minus 1. And what is it going to equal this time? Y equals x. It's going to equal x. You can cross multiply again. What you're really doing is, do y'all agree I'm just multiplying by both sides by x minus 1? So that's what I'm going to do. You can cross multiply, but I just think this is easier to do. What happens to my x squareds? What happens to my negative x's? So does negative 2 equal 0? No. So what does that mean about my intersection point? There's none. So sometimes they're not intersected. Sometimes they are. The intersection is at x comma y. So in this case right here, it is your x value with the y of whatever the asymptote is. Does that make sense? Okay. This one was none. Well, no, never mind. I'm like, don't quote me on it, but I don't think in here we intersect oblique asymptotes, but I'm not sure. All right, last one. What am I going to set my equation equal to here? Y'all do that, please. Isn't it just x minus 1 equals 0? So x equals 1. So the intersection point is at 1, 0. Plot a point at 1, 0. It is. I won't lie to you. All right. Last two things we're going to do. Yeah, there's a little bit more. But these are the easiest parts, hopefully. We're doing x and y intercepts. How do we find x-intercepts? We are going to make the numerator equal 0. To find the x-intercepts, make the numerator equal 0. How do we find the y-intercepts? We are just looking for f of 0. So to find the x-intercepts, you are going to make the numerator equal 0. To find the y-intercept, you just find f of 0. So let's do that. What's my numerator in this problem? X minus 1 equals 0. So what is my x-intercept? 1, 0. Make sure you give me a point for x-intercepts and y-intercepts. To find the y-intercept, I need to find r of 0. So what is 0 minus 1 over 0 squared minus 4? No, you're right. What's my point, though? 0, 1/4. And hey, guys, it's always just going to be your constants. It's always just going to be your constants, because everything else will have 0 in. So everybody plot. We already plotted our x-intercept in this case. So plot 0, 1/4. And then we'll talk about graphing the rest of it tomorrow. Let's just do the x and y intercepts for the next two. So go do that, please. I took my factored one because we already factored it. So what are my x-intercepts here? 2, 0, and -1, 0 are my x-intercepts. I don't want y'all to think that's an intersection. And then my y-intercept, if I plug in 0 squared minus 0 minus 2 over 0 minus 1, what do I end up getting? Give me a point. 0, 2. All right, y'all do the last one. Did you get 0, 0, and 1, 0? And then, so the y-intercept is 0, 0. The bell's going to ring in about 3 minutes, but to do the rest, we're going to make a table to plot random points. But we'll do that tomorrow. Alright, we filled out the whole chart as of today. Tomorrow we'll talk about holes, and then you'll have the rest of class to practice doing these. Yes.